Today for Biostatistics, in this particular recording, I am thinking of the power size and the power analysis and the sample size. And I just wanted to get this recorded before the time slipped away and I forgot about it. Because what we need to do, we need the instructions to install another add-in under data analysis. It's the solver. So I'll come here to Excel and File, Options, Add-ins. You see I've already added it in, but it would be down here under the inactive ones for you. I can't go back and undo it, but anyway, solver add-in, it would just be down here. You'll find it down here in this list, right? And then you would go to the Excel add-ins. You see I now have it checked, and then you click OK. I'm going to cancel because it's already there. I already did this. We get the analysis tool pack and that, so I'm just going to cancel. Now when I go to Home, Data, and I have Solver. Why do I have What if Solver tool that finds the optimal value of a target cell by changing values in the cells used to target. Okay, I haven't done this yet, so I'm just seeing what we can do here. Okay, can I follow this? Let me just try to follow these instructions on the screen. Okay, I got solver. On the solver dialog, select C12. C12 as a set objective cell. Click the value of option. Value of option. I have to keep bouncing back and forth, but sorry about the flashing there. Value of, and enter 0.9. 0.9. Enter C2 in the by changing value variable cells edit box. C2. So you recognize here we're just typing in our cell addresses. You can click on the little spreadsheet thing and go and find it, or you can just type it in here. Enter C2 in the by, okay, and then click solve. Solve down here. So what should we expect to see? Solver tries out different values of the sample size per group until it finds a sample size that satisfies your criterion of 90%. Okay, so the power we selected was 90%. We're accepting a 10% false negative rate. Our beta is 0.1. Therefore, our power is 1 minus that, 0.9 in this case. And if you don't understand that, that means you haven't been reading the chapters in your textbook, so go read your textbook. You need 16 observations per group. Let's see if that's what we get. Objective cell contents must be a formula. Okay, I guess we don't know what's supposed to be in the objective. See, here's a. Let's see, open this in a new window. Okay, more and more things to spend money on. Anyway, we just need to find out what to put in that C12 to start with, right? So the set objective, we'll have to check that out. But this should be the results that it would give us here. You probably can't see it, but it's n per group is 16, alpha is 0.01. That's strange. That really, for power, that should be our beta. Anyway, SSB, MSW, lambda, V1, V2, E, critical F, and the power. So a little more work to figure what out all this means. sums of squares between within. Okay. V2 are degrees of freedom within. Critical F value. Final thoughts. I'm going to print this to a PDF and we'll get it posted. But I just want to take some steps to get closer to using the Excel to work with power and sample size. If I go to my JMP that I have here, let me see if I can get that to come up. Found that already at another website. Go to DOE, sample size and power. We pull this in. I'm just going to do the one sample mean since that was the example I did. We can discover others. Do I seem like a novice doing this? So here we have our alpha at 0.5. Maybe I need to read the chapter. And let's see, I printed this out. So I'll just read it to repeat what I saw on that web page. I've got the web page. Oh, it's hard to read. It's printed out small. 0.05. Okay, standard deviation of 2. The extra parameters I left is 0. We can discover what that might mean. Difference 1.5. So we think might be the difference between the two groups. And we're just going to calculate power with this and say you could leave the sample size empty and put in your power. See this, I'm sorry, I don't know if I'm recalling, I just read some of the chapter on this. We do set our alpha here. We'll accept a 5% false positive, and by setting our, well, we're going to determine what our power would be going forward in this direction. So we would be accepting, so 89% is our power. 1 minus 89 is 11, is that right? So we're accepting a beta, under these conditions, we're accepting a beta false negative of 11%. And we can do an animation script here, and you should recognize this. So this is showing a two-sided. If we do the low side, right, so we got the 0.025 on each side, distributed to each side. Here we've got the 0.05, and you can see where we're getting our false positives and false negatives. We showed this in class. We do only the high side, and all of these become the false negatives. So we got a sample size, an alpha, it's giving our estimated mean, true mean, hypothesized mean difference, right, 1.5, standard error of the mean, our beta value, and the power. I gotta take a look at this. I'm not sure what that's telling us there, but we're all on a learning curve, right? Ability to learn, hopefully I'm still hanging somewhere up here and not in my stage of life tapering over here. Hopefully you're way over here, if this is your learning curve, right? Throughout our life, somewhere at some point we peak and then it begins to taper, right? So I don't want to get over here too soon. Hopefully I'm still somewhere in here, kind of where I was 15, 20 years ago, that what it would be. Anyway, I'm just going to stop there. We'll investigate these to learn more on how to go backward, put things in, and determine what sample size would be optimal. The chapter in our textbook, the Essential Statistics for the Pharmaceutical Sciences by Philip Rowe, talks about all these very nicely, and I'll leave you to discover some things on your own. And for now, we'll just end it there to get things going.